Question 15.11. A compound with the molecular formula C5H10O2 has the following NMR spectrum. Determine the number of protons giving rise to each signal. So we have a total of 10 protons in the compound. We have some integration values down here below, and we want to determine the number of protons that are giving rise to each one of these signals. So the approach we're going to take is we're going to divide each one of these numbers by the smallest number, which is 33.2. So if I divide all of these by 33.2, you can just do a little bit of mental math and probably figure that out. But what you get is obviously 1 here, and this is very close to 1. And then for the other two, I get a number that's close to 1.5. Now there's no such thing as half a proton, but if I multiplied all of those numbers by 2, the numbers that I would get for the relative integrations would be 2, 3, 2, and 3. And if each one of these signals was to represent 2, 3 protons, 2 protons, and 3 protons respectively, that gives me a total of 10 protons. So therefore, the triplet at 4 must represent 2 protons. The singlet at around 2 parts per million must represent 3 protons. The sextet past 1.5 parts per million, that must represent 2 protons. And then this triplet down here, that must represent 3 protons.